Hi there. Today, now we're going to talk about a topic in research methods. So, real basic stuff in social psychology. I'll keep it relatively brief because this is not a methodology course, but you have to have at least some. As we go through some of the experiments that we discuss in this class, you'll need to have at least a basic understanding of how the research process works in order to understand what it is we're talking about and seeing. Right. So it is somewhat important. Okay? Here's the deal in science. This is how it works. In science, we usually want to know big answers. Just grabbing. What is the opinion of TWU students of the university president? Okay. So it's a pretty big question. In other words, you want to know the opinion of every student on campus. Well, there's just too many students on campus. You couldn't find them. Some are part-time. Some are taking a semester off. I don't know. Okay. So what you'll do is you draw a sample. Let's say you draw a sample of 100 Wesleyan students and get their opinion of the president, and then average it, get the average of the sample, and then you'll use this piece of information that you draw from the sample to make your best guess of the opinion of the president. So if you draw a sample of 100 and they say, oh, I like the president, on a scale of 1 to 10, a 7 or something. So the president's got a 7 average. This is an average we obtained from a sample of 100 people, but we say, now I haven't actually asked every single person at Wesleyan, but if it were possible to do that, my best guess is the average would be 7. Okay? We'll take the information from the sample, we'll make an inferential leap, right? Remember, statistics come in the form of description. You describe the sample. Inferential, you use the sample to make inferences about the population. Okay? So, in other words, in science, we often want to know truths that we can't ask because they're too big. So we get smaller things and use these samples of information to make my best inference, not guess, right? Inference about the population. Science is a self-correcting thing. Okay? What happens is you go to the top left corner there. The scientific method starts with observations. Okay, it's empirical at its very core, or previous research, which of course had observations. And so what happens is we develop a theory. A theory is a tentative explanation for observations that have been made. So I made some observations. I have a theory. So let's say I observed certain things. Okay, when students got good grades on the exams, they smiled, and then guess what? Later on, they pushed in their chairs when they left the room. They held the door for the people behind them. But people that had bad grades were less socially polite, something like this. So I might take these observations that are really uncontrolled and think, let me see how I might be able to think about that. I have a theory that says happiness influences helpfulness. That's my theory. Okay? And so my theory, happiness influences helpfulness, allows me to create a testable prediction of that theory. So I then have a theory that says, I believe that if people are put in a good mood, then, if put in good mood, then they will be helpful. Okay? And so now I might use this hypothesis to generate a research project. Like, I'm going to take 100 people and 50 of them, I'm going to give them something yummy and put them in a good mood, and 50 of them, I'm going to take something away and put them in a bad mood. Then I'm going to give them an opportunity to help. Like, a researcher walks in the room and drops a box of pencils, right? How many pencils do you help pick up? And so now what's going to happen is I'm going to generate observations. Remember, the whole scientific method started with observations, but those first observations were uncontrolled observations. This time around, the observations are controlled in a controlled setting. And by doing this, these observations that I receive will then allow me to test that theory. Well, did I support the theory? Did I fail to support the theory, what's going on? Okay? And the process repeats itself. Maybe the theory gets modified. Oh, well, it turns out that if you make people happy using candy bars, you get a different result than if you make them happy using a good grade on a test or something. So the process is self-repeating. It repeats itself. It feeds on itself. Okay? So, theories, well, I just said that. So theories, as I said, a tentative explanation for what I've been observing. A hypothesis is a testable proposition of that theory in the form of an if-then statement. If this happens, then that will occur. Well, research comes in different kinds, and my favorite is obviously the experimental methodology. I mean, both my master's degree and my PhD are in experimental psychology, so clearly I'm biased. But there's other ways of gathering knowledge, right? And observational research is one of them. Observational research is useful, but I'll tell you that there's four goals of science. Okay, to describe, explain, predict, and control. And in fact, psychology is really all about describe, explain, predict, and control behavior and mental processes. That's the science of psychology. Lovely. So observational research can allow us to describe things, and they do so very well, okay? But you can't really do much more. You can't do the explain and wait, describe, explain, predict, control. You can't do the other three, okay? But, it's a start. And so naturalistic observation is to observe behavior in a real environment. And yeah, I mean, this is social psychology. Fact is, when human beings are in a research laboratory, they act different. They don't act real. They show you their best behavior or something like that, all right? Instead of real behavior. Case studies are Sigmund Freud's thing, but an intense observational study of one or a very small number of people. Case studies are very useful for certain things, but don't pull a Freud. If you find something to be true in a case study, do not use that information from a single case to generalize to a broader population. But that's another class. Trust me, I'll go on a good old Freud rant if you want one. So survey research it's like naturalistic observation, sort of, except we're asking you to observe your own behavior. All right? How often do you take out the garbage in your home? Something like that. So instead of me physically getting in there to observe the behavior, you give me a report of that behavior. But what happens is that often people just tell you what they want to tell you, right? And it turns out that the way that you use wording in a sample can greatly, or wording in a survey can greatly influence the results you get back. Clearly, here's one. What was it? 27% agree with government censorship of media, sex, and violence, but 66% think more restrictions to what is shown on television. So how is more restrictions not the same as government censorship? Because censorship is a dirty word and nobody's going to agree to it. Okay? And so all of a sudden, if we can change the way the question is asked and change so radically the outcome, what are we really measuring? Okay? So opinion polls are exactly what they are. I mean, they're flawed fundamentally. Correlational research is sort of like descriptive research, because correlational research allows us to describe a relationship between two or more variables. Okay, so it is descriptive in this same way, but it describes a more complex relationship rather than describing a single variable. So here's a correlation. Social status and health. There's a positive correlation between the two. The higher your social status, the more health you will have. Yeah, sure. Self-esteem and academic achievement. The higher your self-esteem, the higher your academic achievement. But here's the problem. We have no idea. If two things are correlated, we don't know A causes B. We can't establish that. We don't know A causes B. Okay? But remember, describing and predicting are two of the elements of psychology as a science. And so Correlations can describe the relationship between variables, and they allow for prediction. If somebody has high social status, I predict they will have good health. Got it? Predict. But the old phrase is correlation does not imply causation. I can imagine somebody that has, let's say, high self-esteem. High self-esteem makes you feel good about yourself, makes you try harder, gives you better academic achievement. But I can also imagine people that have high academic achievement will think highly of themselves and have high self-esteem. So clearly, the relationship is true, but I have no idea. Maybe in fact there's a third explanation out there, like a supportive family environment causes both self-esteem to go up and academic achievement to go up. I don't know. I do know that if I see high academic achievement, I predict high self-esteem, and if I see high self-esteem, I predict high academic achievement. But boy, oh boy, that word cause is out. And so when it comes to the explain and control part of the goals of science, psychology as a science, we ain't getting there. Correlations can look in positive or negative. Okay, in fact, this one is better. See the one on the left and the right? These are, okay, number one, the one on the left is an absolute zero correlation. By that, what I mean is, again, prediction. If I know the value of X, it does not allow me to say anything about the value of Y. I have no idea. I can't predict nothing. The one on the right also would look like a zero correlation, but that is because you're looking for a line, okay? Right here we can see quite clearly in both of these graphs that this is what we call a linear relationship, a relationship that is in form of a line. This one is a relationship, and it is quite a powerful relationship, but it is in the form of a curve. And so traditional correlational work would fail to find this, okay? Other far more advanced statistical work would find it. So we see here with positive correlations between two on the left side, as the value of X gets larger, the value of Y gets larger, right? As one goes up, the other goes up. As we see on the right one, as the value of X increases, the value of Y decreases, okay? But whether it's positive or negative does not impact how good you can predict, okay? If you have a strong positive correlation and a strong negative correlation, you got the same prediction out of them. Okay? That does not affect them. Okay, some positive correlations, height and weight. Yeah, you know, the taller you are, the more you tend to weigh, right? And that is correlations, tends. Age and job satisfaction, okay? And so all of a sudden, the older people tend to be more satisfied with their jobs because generally older people are in careers, not jobs, right? Salary and years of education. Generally speaking, the more years of education, the higher the salary. Not always. Just look at, university professors. Okay, high education and ain't got no money. Whatever. Okay, so there's many of these relationships in psychology. Negative ones, things like grade point average and number of hours watching TV per day. So as the number of hours watching TV per day goes up, grades go down. Okay? And so that's a negative relationship, but it's still very predictive, right? Stress and health. As stress goes up, health goes down. Okay? And so check out this. This is why I became a psych major. Okay? It's a good story. You may have heard this in the experimental class, but you know, second time's a charm, I think. So here I was as a freshman or maybe first semester sophomore in college, I don't remember. And I was sitting in the back row. You see the layout of this class. It was a big old lecture hall, big old pit class. We called them pit classes. You know, big auditorium kind of thing. And you see the way they designed it, and it was really kind of freaky the way they did it. And so here I was way back in the last row. Last seat, last row. I mean, look at that. It even these little side seats, they went even further back than the middle did, right? So I'm all the way back there. And then the professor comes up and he says, he's trying to explain negative correlations, and he says, there is a relationship between the row you sit in class and the grades you receive, a negative relationship. So as row increases, as row goes from 1 to 2 to 3 to 4, grades go down. So here I am, a little freshman, and going, wait a minute. I'm sitting in the last row. Is this guy seriously telling me I'm getting -20 on this test? No, no, no. Bullshit, okay? I'm going to prove him wrong. All right? I am going to prove the dumb shit wrong. And so what I did was I went every single day early to make sure I would get that seat, okay? To make sure I stayed back there. And I studied for that class. I worked for that class. Man, did I work for that class. I got 109%. I had the highest grade in the class. And I'm like, look at you in your face, old man. You're stupid. I'm smart. But remember, the word I was saying about correlations is tends to be. And my little defiant demonstration did not change that tendency. The tendency remained true, all right? Despite the fact that I defiantly tried to show him he was stupid, right? In the end, Dr. McCann was exactly right, and me, the dumb freshman, was exactly that, the dumb freshman. So here is another interesting correlation, and this is a correlation between the height of a grave pillar and the age at death. Okay, so they have low grave pillars, medium grave pillars, and high grave pillars, and then the age at which they died. Okay, and so what's going on here? Well, it feels like there's a relationship, and the relationship is that people who live longer have higher gravestones. Aha! So if you see the height of a gravestone, it will allow you to predict how old the person was. Okay? Well, what we find is that the real relationship probably has to do with like people that make more money are able to buy more healthcare products and stuff, and therefore also have enough money. So all of a sudden, money becomes the thing that explains both the height of the gravestone and the age at which they die. Okay? Cool. Study. Wow. Feel free to read that. The main thing to read out of that is where it says, can participants be randomly assigned? Okay, I'll describe it very briefly. Random assignment. In fact, no, I have an experiment example coming up, and I'll get into it. But without random assignment, you do not have an experiment. With a random assignment, you might have an experiment. And so this is the critical difference between experimental research and non-experimental research. It is experimental research that allows for control. Okay? Let me very briefly explain this idea. If you know A causes B, okay? And B is a good thing and you like B, and you know A causes B, turn on A and B will follow. See how that worked? I love it. If B is something you do not like, I know, turn off A and B will follow. All right? So if you can establish an A causes B relationship, you are in charge of the world, okay? Because the goal of science is not just to understand the laws of nature, but it is also to make the world a better place. Thank you, Francis Bacon, all right? Make the world a better place. And it is the understanding of these causal laws that allow us to make that happen. Okay? All right, so I love it. So, experimental, control, manipulation, causal, I say it. Okay? Experimental research is both good and bad. As I say, it's got advantages and it allows us to find them. It's good in that it has high internal validity, and I'll describe that a little bit. But it's not all good. As we already even anticipated, when people are in a research laboratory and they know they're being... Anytime somebody knows they're being watched, they don't necessarily give you real behavior. They give you edited behavior. Okay? The goal of science is to discover real behavior, not edited. I don't even define it? I didn't even define it. That's stupid. Internal validity, okay, is I want to be able to say if A does in fact cause B, will I discover that thing? In other words, it's a function, internal validity is a function how much experimental control I'm able to use in the study. The more control, the higher the internal validity. But what we find is that there's a second kind of validity, and that is ecological or external validity. And so what we find is laboratory experiments tend to have low external validity, that the behavior, even if you do find a good causal relationship, A causes B, it's likely that the causal relationship that you discovered really will only hold true in that research laboratory and may well not reflect how the world really works. Okay? So experimental research, we use dependent variables. Okay? And so dependent variables in psychology are, all right, researchers manipulate an independent variable and measure changes in the dependent variable. Remember, A causes B. If I manipulate this independent variable, then if independent variable, then dependent variable. If I modify this independent variable, then these changes in the dependent variable will occur. Or the dependent variable, the scores on the dependent variable depend upon which level of the independent variable you were put in. So whatever, it's not an experimental class, and I'm trying to give a really big idea here. But what I do want to mention here as a very important idea is that so much of what we're interested in psychology is what's called a hypothetical construct. It's things that are pretend. I'm going to be talking about a hypothetical construct in a few minutes. It's going to be self-control. Okay? It's a very interesting topic to study. But self-control does not have a tangible existence, right? I mean, I can't have a meter, liter, or gram of self-control. Instead, we have to think about what behaviors do people exhibit in the act of self-control. We can measure behaviors. We can quantify behaviors, right? And so what happens is, by definition, the things we're interested in are pretend, hypothetical constructs. They do not exist. We use operational definitions to define these hypothetical constructs in terms of measurable behaviors. Okay? Very cool idea. Very important. As we said, independent variables are those things we manipulate. Okay? And therefore there must be two or more levels. If there's not two or more levels or conditions, often we hear of the experimental group and the control group. That's fine. Or it could be, quiet room, medium noise room, high noise room. Okay? So it could be more than two levels. It could be all kinds of manipulations involved. Control variables are those things that you, the experimenter, are in charge of making sure. Like, say, for example, you're doing a study on helping behavior, and you're thinking, if it's cold, people may not be as helpful because, it's cold and they want to get out or something. But this is not an experiment. Remember, this is an experiment between happiness and helpfulness, like we described a little bit back, right? And I think the temperature of room could make a difference. Aha, I got it. I will make sure the temperature of the room is exactly the same every single time I run this experiment. Okay, sweet. I've held it constant. I've controlled it. Therefore, when I go later and want to say A causes B, I am 100% certain that temperature of room is not interfering with my ability to say A causes B. Okay? Confounding variables are a little different. And I'm probably just going to let that go because it's a sufficient explanation is far more than I think we need for this course. So, true experiments. Okay, only true experiments allow for the causal. Leave that. Yeah. What are the concerns? Again, that's more than we need for this class. Now, here's a pretend experiment in social psychology. Okay, I actually read this one research project, because I study self-control. So I read this interesting research project. They took some chimpanzees, and these chimpanzees were given access to a mechanism. Every single day, they go through this procedure, so they're familiar with it. And what happens is it gives candies, okay, like M&Ms or something like that. And it gives like one M&M every 5 minutes, okay? Now, as long as you don't grab any M&Ms, it just keeps on building up them M&Ms. But the moment you grab for an M&M, it stops. Whatever's in there is what you get. Okay? So this is the ultimate game of self-control. The longer you can control yourself and resist the temptation to grab the M&Ms, the more M&Ms you get. Okay? And so, interesting. So in this study, what they did was they gave monkeys this task to do, and then on certain trials, they would give them things to distract them, things like toothbrushes and stuff. Whatever. Well, it turned out that when they didn't have distractions, the monkeys basically sat and looked at the machine. When they had toys to play with, they got distracted. They didn't look at the machine. Okay? And those monkeys that didn't look at the machine and were distracted got significantly more M&Ms than the ones that didn't have toys and weren't distracted. And so the conclusion they made was out of sight, out of mind. I was like, okay, that's cute. I don't think that's nice. So let's try this with little children. Out of sight, out of mind. So I'm gonna explain a little paradigm that is used often. This is a version of Walter Mischel's work on self-control. And what happens is you bring in children, they're like 4 and 5, somewhere in that range, preschool, and you put a marshmallow on a plate on the table in front of them, and then what you do is you say to them, I'm going to leave the room, okay? I'll come back in a little while, and if you wait, and if that marshmallow is still on the plate, I'll give you a second marshmallow, okay? So you just got to wait for me to come back, and then you have 2. And there's a wonderful videos of this online, by the way. It's just Google the marshmallow study, and you'll find all kinds of stuff. So imagine I'm going to test this idea out of sight, out of mind. Okay, and so let's say half of the children are going to have the marshmallow on the plate, but it's going to be covered by a bowl. And half of the children are going to be given a marshmallow on the plate, but the marshmallow is open and exposed. Okay, so now here's the problem. We want to measure self-control, but I need to operationally define self-control. And there's a lot of ways I could operationally define this variable. I'm gonna pick one. If you watch the videos online, a whole lot of the kids, they pick up the marshmallow, they gnaw little corners off, they pee, and there's like a gooey mess left on the plate at the end, right? So here's what I propose. When you come back after 15 minutes, weigh the marshmallow and find out what percent of the marshmallow is still remaining. Okay? Out of the total 100% you started with, what is remaining? And you see what I've done here is I've quantified self-control. Self-control doesn't exist. It's a hypothetical construct. I quantified it. I found a way to make publicly observable, repeatable, quantitative data. Okay? Wonderful. You've quantified a hypothetical construct. All right, so in this cute little study, and it's imaginary, I don't think it's been run, but I guess it could. So now, check this out. Is this study going to have high internal validity? And remember, internal validity is like, if there's a causal relationship, did I discover that causal relationship? Something like that. And chances are, yeah, I mean, it probably has high internal validity, but only to the degree that I exhibited control, okay? Control of temperature of room. Control of, did I use the exact same experimenter? Did the experimenter use the exact same instructions for every child? Did I use the same time of day, etc., etc.? There are a ton of extraneous variables that could be influencing. And so what we find is I will hold constant those extraneous variables that I believe are critically important, like temperature of room perhaps. Okay? But ultimately, there are so many extraneous variables possible out there, like humidity of room. What? Yeah, there are so many things you couldn't even possibly anticipate that could possibly interfere in this relationship. So that's where random assignment comes from. Because we used random assignment to randomly assign these children to these conditions, we hope that all these other extraneous variables that I couldn't even imagine will balance out and fall equally or nearly equally into the 2 different conditions. Does this laboratory experiment have high external validity? No. No, I'm fairly certain it doesn't. Okay? like 4 to 5 year olds, they know when you're in a school environment, you need to be on your best behavior. And so all of a sudden, it's very possible that these children would be demonstrating self control at levels that are far higher than they would ever demonstrate in any other context. Or if you put college students in the marshmallow study, they probably wouldn't act the same. Of course, the college students would just pull out their cell phones, but whatever, man. Okay, so yeah, whatever. That looks like a good one for you. And here's a good summarization of correlational versus experimental work, including the advantages and disadvantages. All right, so that's what I got on the first topic. So pretty soon I'll come back and hit you up on topic 2.